I am Ananiqua Smith. I teach 7th grade science at Brain Middle School in Alexandria, Louisiana, a part of the Rapides Parish School District. I am privileged to teach a diverse population of learners. The students who make up my classroom stem from socioeconomic, religious, and different ethnic backgrounds. This allows for a plethora of perspectives, input, and reactions in response to our content. Throughout the course of this year, students of all learning types have participated in units like metabolism, where they learn that molecules from food and air go through a series of chemical reactions to form new molecules for energy and growth. They participated in a metabolism engineering internship as well. Using engineering practices, students developed health bars for disaster relief persons in order to meet their metabolic needs. After a dive into life science, students got a taste of physical science as well in the phase change and chemical reactions units. The Amplify Science curriculum utilizes Louisiana science standards. These standards are paired alongside real-world phenomena and make-believe science career roles for the students to fulfill. I am devoted to facilitating a learning platform for my students to have an engaging yet rigorous opportunity to refine and develop science practices. Students are learning to ask questions, evaluate evidence, engage in argumentation, and more. The current unit is traits and reproduction. Students currently serve as genetic researchers, aiming to discover why a family of Darwin bark spiders have different silk flexibility traits. This serves as the anchor alongside the Louisiana Science Standard for structure and function. Moreover, students learn DNA codes for pairs of genes, which provide instructions for the structure of our proteins. These proteins are what produce the specific traits that make us so similar to our parents and siblings, yet so different. Prior to this lesson, students have deepened their understanding of the standard for structure and function, while interacting with spider silk proteins and the functions they produce in their respective spiders, through digital, visual, and physical models alongside scientific articles. The lesson you are about to watch is titled, Gathering Evidence About Inheritance. In this lesson, students can investigate how genes inherited during sexual reproduction cause offspring to have different gene combinations. They use the digital sim to gather evidence to either support or refute a claim about inheritance. You will notice that students sit in diverse groups of 6 to allow for effortless transitions for partner and group work when the activity allows. Thank you for joining my classroom where everyone is a scientist. Same parents. Our chapter 1 question, we asked, why are they making different traits? That's how we started. And you guys learned it's because they're making different proteins. In chapter 2, we asked, why are they making different proteins? And you guys said because they have different genes. So in chapter 3, we are asking, why are the different spiders making different gene combinations even though they have the same parents? Or why is it that you and your siblings have the same parents, but you all still look a little bit different? You still have different characteristics from each other. So in lesson 3.2, you're going to gather evidence about inheritance. Your I can statement says you're going to 30 seconds. Offspring's traits depend on which parent the offspring inherited more genes from. Maybe you think that that is true. Recap what we've learned so far. Alright, where does it start? What have we learned so far? Amari, where does it start?
With the parents.
Okay, but we haven't really talked about that. What have we said? What did we just say about what comes before, or how do we get our traits? Where does it start? Okay, you're skipping, you're going backwards, we're not there yet. What comes after that? Yes, their genes. That's kind of where we are for the most part. It's good that y'all know. That is going to be the next step. Okay? And what do we know about genes? Sebastian?
They're the instructions for the enzymes that make the protein molecules.
Right. They are the instructions they're gene copies, but those gene copies are instructions for what? Maybe see the key concept wall to refresh your memory. It's about traits and reproduction. A part of the article, why are identical twins rare? This is what you read the last time that you were in class to help you better understand how organisms inherit their genes. So when you look at the article today, you're going to read that second paragraph on page D2 and the first paragraph on page D3, okay? So you're going to reread and annotate those. Investigation question. How do organisms get their genes?
That's how we get our 2 gene copies.
Okay, so you have mom's cell and dad's cell combines. Anything else that's important that we need to add under how do organisms get their genes? Anything else? What about in paragraph 3? Flip back there. Anybody? Sebastian.
Whenever they come together, the fertilization.
Say that again.
Fertilization.
Okay, so they have to combine, and then there is fertilization. Anything else? Yes, David.
The genes you get are random, so it's the traits can vary if you do.
Very good. Genes are random, so our traits are going to vary. The second and third